All clean hands now. Now what we have here is an open flame and a piece of paper. I want to show you what will happen when I put this paper into the fire. Well, it burns, and chances are that you already know that's what is going to happen. No magic there. But what if I tell you that I'm going to boil water using the same paper that I used a while ago? You're probably going to tell me that I'm crazy, but I bet you're going to stick around just the same. Why? Because it's interesting, and that's what science is. Crazily interesting. So place a ring stand over this candle, or you may use this right away. Then we're going to boil water in the paper bag or in this paper hat over an open flame. Alternatively, you may use a box using a printer paper or either paper clips or scotch tape. So here we have the water, and look what happens. The paper did not burn. So what's the magic here? Paper is a poor conductor of heat, so the water heats slowly. Conduction of the heat through the paper eventually increases the temperature of the water to its boiling point. The heat keeps the water from seeping through the bag, while the high heat capacity of the water keeps the paper from igniting. Common sense would tell you that it's impossible to boil water in a balloon. But after what you had just seen, could it still be far from reality? Well, 4 weeks into this module, and you'd probably know the line. There is magic in science, and there is science in magic. So, we're going to blow up a balloon just as you normally would and tie it off. Now, we have already a lighted candle and place it in the middle of the table. Put on your safety glasses because it's time to pop the balloon. Hold the balloon a foot or two over the top of the flame and slowly move the balloon closer and closer to the flame until it pops. You'll notice that the flame doesn't have to even touch the balloon before the heat melts the latex and it pops. Let's just say you had to prove what you already know. Let's repeat the experiment, but this time the bottom of the balloon will have a layer of water inside. So fill the balloon to the top with water. It probably holds a few milliliters or few ounces, 60 ml for the scientists, and then blow it up with air. If you accidentally let go of the balloon before you tie it off, you'll spray yourself with water and your friends will love it. Just tie off the balloon and get ready for the next step. Slowly lower the water-filled balloon over the candle and watch as people start to run. Everyone knows it's going to pop, but for some strange reason, it doesn't. If you're very brave, you can actually allow the flame to touch the bottom of the balloon. Just like so. And it still doesn't pop. Remove the balloon from the heat and carefully examine the soot on the bottom. Yes, there's soot and the balloon didn't pop. Before reading the explanation, try to figure out why the layer of water kept the balloon from popping. How does it work? Well, water is a substance great for soaking up heat. The thin balloon allows the heat to pass through very quickly and warm the water. As the water closest to the flame heats up, it begins to rise and cooler water replaces it at the bottom of the balloon. This cooler water then soaks up more heat and then the process repeats itself. In fact, the exchange of water happens so often that it keeps the balloon from ever popping. The soot on the bottom of the balloon is actually carbon. This carbon was deposited on the balloon by the flame and the balloon remains undamaged. Using water to control heat is a valuable process. In fact, firefighters in Colorado often use a polymer foam to control large wildfires. Since polymers soak up a tremendous amount of water, they are useful in controlling and stopping the heat energy in the fire. Now here's the post Easter egg hunt activity for you. I'll show you how you could get a seemingly large egg to fall into a bottle without having to push it inside. We're going to need a bottle and a medium-sized egg, an open flame, and a piece of paper. Set the piece of paper on fire and drop it into the bottle. Set the egg on top of the bottle, small side pointed downward. When the flame goes out, the egg will get pushed into the bottle. If you just set the egg on the bottle, its diameter is too large for it to slip inside. The pressure of the air inside and outside the bottle is the same, so the only force that would cause the egg to enter the bottle is gravity. Gravity is insufficient to pull the egg inside the bottle. When you change the temperature of the air inside the bottle, you change the pressure of the air inside the bottle. If you have a constant volume of air and heat it, the pressure of the air increases. If you cool the air, the pressure decreases. If you can lower the pressure inside the bottle enough, the air pressure outside the bottle will push the egg into the container. It's easy to see how the pressure changes when you chill the bottle. But why is the egg pushed into the bottle when heat is applied? When you drop burning paper into the bottle, the paper will burn until the oxygen is consumed. Combustion heats the air in the bottle, increasing the air pressure. The heated air pushes the egg out of the way, making it appear to jump on the mouth of the bottle. As the air cools, the egg settles down and seals the mouth of the bottle. Now there is less air in the bottle than when you started, so it exerts less pressure. When the temperature inside and outside the bottle is the same, there is enough positive pressure outside the bottle to push the egg inside. Heating the bottle produces the same result. The bottle and the air are heated. Hot air escapes from the bottle until the pressure both inside and outside the bottle is the same. As the bottle and air inside continues to cool, a pressure gradient builds, so the egg is pushed into the bottle. Well, it's time to say goodbye again, and I hope you had fun and a lot of magical science learning from our 4-part science module. So the next time you see something magic, remember that science is at work. Bye-bye!